From the highest resolution image of the Great Red Spot to never-before-seen views of Jupiter's aurora, here is the largest gas giant in all of its glory. We begin with this high-resolution image of Jupiter that was taken by NASA's Juno spacecraft during its 47th orbital pass around the planet. The photo reveals an incredible amount of detail, including several of the cloud bands and the Great Red Spot itself. These iconic features are over 16,000 miles across, and they stretch almost as far as Earth's entire diameter. But even more amazing than the size of the storm is the dynamic range in the image. You can see the height difference between the tops of these towering clouds and the shadows below them, and it's a remarkable 30 miles high. But sometimes it's the small details that are the most striking. And just look at this close-up of Jupiter's swirling storms. Here we can see a rich tapestry of colors and textures, from the lighter areas of high-altitude clouds to the darker patches below. This beautiful illustration was created using data from the Juno cam, and it shows what we think Jupiter's atmosphere looks like if we were to remove the overlying layers of clouds and haze. It also gives us a glimpse of the composition of the planet's atmosphere, which is mostly hydrogen and helium. In this image, we get a sense of the truly enormous scale of the Great Red Spot. In the middle of the storm, we can see tiny dots that represent scientists who are standing next to each other. And back at Earth, we can see our home planet in the upper left-hand corner. It looks tiny next to the massive storm, but it really puts into perspective how big the Great Red Spot is. In this image, we can see another amazing feature of Jupiter, its auroras. These bright lights are located near the planet's north pole, and they are similar to the northern lights we see on Earth. But the auroras on Jupiter are much more extensive, and they glow with an eerie light that is not emitted by our Sun. These auroras are powered by Jupiter's strong magnetic field, and they are some of the brightest objects in the solar system. They were captured by Juno's Stellar Reference Unit, which is used to keep the spacecraft pointed towards Earth. It's designed to take pictures of stars, but it was repurposed to capture these stunning auroras. Here's another photo of Jupiter taken by JunoCam. It's one of the best photos of Jupiter's four largest moons, Io, Europa, Ganymede, and Callisto, also known as the Galilean moons. The Galilean moons are named after the astronomer Galileo Galilei, who discovered them in 1610. He saw them as four stars in the sky, and they became the first objects ever observed orbiting a planet other than the Earth. Io is the closest moon to Jupiter, and it's the most volcanically active body in the solar system. We will see more of Io later. For now, let's move further out and take a look at Europa. In this image, we can see Europa up close. It's covered in a layer of ice that makes it look like a giant cracked eggshell. But don't be fooled by its calm appearance, because underneath that icy shell lies a vast ocean of liquid water. We'll see more of Europa soon too. Meanwhile, the next moon along is Ganymede. It's the largest moon in the solar system, and it has its own magnetic field. It's also the only moon that we know of that has active volcanoes. Finally, we have Callisto, the farthest away from Jupiter of the four large moons. It has the most craters on its surface, and it is the least volcanically active. Next, we're going to leave the Galilean moons behind and focus our attention on Jupiter again. This time, we're going to look at the rings that surround the planet. They're not as well known as Saturn's rings, but they are just as beautiful. In this image, we can see part of Jupiter's ring system. The rings are intermediate in complexity, halfway between the more extensive set around Saturn and the simpler rings found around planets like Neptune and Neptune. Jupiter's rings are intermediate in complexity. They are intermediate in complexity. They are intermediate in complexity. Now we have another image of Jupiter's magnetic field. Jupiter has an incredibly powerful magnetic field that extends thousands of miles into space. In this image, we can see the magnetic field lines extending out from the planet. They form a protective bubble that shields the inner solar system from the solar wind. This magnetic field also traps charged particles from Jupiter's moon Io, creating vast radiation belts around the planet. These radiation belts are some of the most intense radiation environments in the solar system, and they pose a serious threat to spacecraft like Juno. Here is a side-by-side comparison of Jupiter and Saturn. Saturn is larger than Jupiter, but Jupiter has a much stronger gravitational pull. This is due to its greater mass, and it means that Jupiter has a much more extensive magnetic field than Saturn. As a result, Jupiter's magnetic field extends much farther out into space than Saturn's. This is why Juno orbits Jupiter at a distance of 50 million kilometers, while Cassini orbited Saturn at a much closer distance of 9 million kilometers. Speaking of distances, here is another infographic that gives us a sense of the scale of Jupiter within the solar system. Jupiter is so massive that if we were to shrink the Sun down to the size of a basketball, Jupiter would still be nearly 12 times larger than it. Here is a photo montage that spans the history of human exploration of Jupiter. It begins with an image taken by the Galileo spacecraft in 1995 and ends with a photo from the Juno spacecraft taken in 2021. In between, we can see images from the Voyager, Cassini, and New Horizons missions. Each new image reveals more detail and shows the incredible progress that we have made in exploring our solar system. Here is another image of Jupiter taken by Juno. It shows the different types of clouds that can be found on the planet. There are 3 main types of clouds on Jupiter: light, medium, and dark. The light clouds are made of ammonia ice crystals and they reflect sunlight, making them appear bright. The medium clouds are deeper red and they indicate the presence of complex organic molecules. The dark clouds are opaque and they contain more hydrogen sulfide, making them appear black. This image also shows the incredible motion of the clouds. From the top down, the clouds move in different directions and at different speeds. The winds on Jupiter can reach speeds of over 400 miles per hour, and they form giant jet streams that circle the planet. Finally, we end our journey to Jupiter with this artistic rendering. If we were able to fly through the clouds and descend deep into Jupiter's atmosphere, what might we see? The artist behind this image imagined that there could be hazes that obscure the view, but that if we could punch through them, we might see towering pillars of gas and dust rising up from the depths of the planet. At the bottom of the image, we can see strange weather patterns that have never been seen before. Jupiter's atmosphere is a violent and chaotic place, but it is also one of the most beautiful and intriguing parts of our solar system. Thank you for joining me on this tour of Jupiter, the giant stormy planet. I hope you enjoyed this video and learned something new. If you want to see more videos like this one, make sure to follow. With that said, here is your reminder to stay curious. If you love this video, go ahead and watch this one next. I'll see you there.